I can compare decimals. This should be a review lesson. It's definitely covered in lower grades, but let's just go ahead and compare 4.2 and 4.21, or if you want to read it correctly, 4 and 2/10 and 4 and 21/100. Now, here's my basic setup here. Stack them vertically on top of each other. So here's 4.2 I'm rewriting, and I'm going to put that right over top of 4.21. Notice I said line up the decimals, so there's my decimals perfectly lined up. If you get sloppy, you're going to have problems. And then add zeros if needed, so that way they're the same length. You can see we've got two numbers after the decimal spot, so let's just put a 0 in there and I'll make it red to let you know that we added that in. Now, just look at it and you tell me, is 21 bigger than 20? Yep. And since they have the same whole number, that part's even, so we're just really comparing the decimals. I know that 4.21 is bigger. So 4.21 is greater than 4.2. So again, stack them up vertically, line your decimals up, so that way they're right on top of each other. And if you need to add zeros to make them the same length, go ahead and do that, and then you can just compare. Again, you could also take out the decimal too. Is 421 bigger than 420? Yeah. So this is your bigger number. So that one might help you as well. Pause the video, go through and do these 4 problems. Hit play when you're ready, and we'll see how you did. Okay, so let's go ahead and just rewrite it. Here's 5.1, and here's 5.001. And I'm trying to be as careful as I can. Let's put in the extra zeros there. Now you tell me, is 5,100 bigger than 5,001, or is 100 bigger than 1? Either way, I think it's pretty clear that this is your biggest number. So 5.1 is bigger than 5.001. Let's go down and take a look at this one. Again, be very, very careful with how you rewrite this. We have 4 zeros there after the decimal. So 1, 2, 3, 4, and there's the 1. And now let's go through and rewrite this one. We have 1, 2, 3 zeros after the decimal. And since we do not have the same number of digits after the decimal point, let me go ahead and put this 0 on there. And now, if you would just give me a second to get a highlighter, let us go and compare. There's nothing but zeros all the way up to here, so that one's like 1. This is no zeros until we get to here. What's bigger, 10 or 1? Yep, so it's this one right here. Let's see, this is tenths, hundred thousandths. It's 1/10,000th is how we would read that. And let's just go ahead and write that up there. It's less than. There we go. And it's messy. I apologize. So let me go through and fix that. We had 3 zeros after the decimal spot. There. That's better. So 1/10,000th is greater than 1/100,000th. Number 8, a lot easier. We had 7.2 and 7.02. Add the 0 on there. The 7s are the same, so we're really just comparing the decimals at this point. 20 is bigger than 2, so 7.2 is greater than 7.02. And the last one, 0.91 or 91/100ths, and 0.910,000ths. And this time we've got to add a 0 on here, and do you see that? It's exactly the same. So this is equal to that. 91/10ths is equal to 910/100,000ths. Excuse me, let's see. Tenths, 100,000, 910,000ths. That's how we could read that. Hopefully, you've got the basic idea of just stacking them and then comparing your decimals there. Be careful. Let me show you one last thing to be careful about. If we were comparing 7.01 and 1.02, here's what I'm saying. 0.01 is smaller than 0.02. However, when you consider the fact that the 7 is a lot bigger than the 1, I know that this is greater than that. 7 is greater than 1. The decimals don't even mean anything. But when you start looking at comparing two numbers where the whole numbers are the same, or the decimals are just kind of really close to each other, that's when you want to use my method.